So, turning salt into a crystal, huh? Cool, but how do I actually make that happen? I've got a gut feeling about this, but okay, here's the plan. I'm gonna ninja my way into the kitchen. I will grab that salt from the cabinet, and mother won't suspect a thing, right? Then I will sprinkle the salt onto a plate like this. After that, I will pour some hot water over it before giving it a good stir. Then I will let it dry for a few hours. I did it! I put it off, but for some reason it's not taking the exact shape I had in mind. Alright. I'm giving it another shot, but this time I will do it properly. First, I need to heat the water. I mean, it's the only way for water molecules to gain energy to interact and cause the salt molecules to break apart. Then, I'm going to put a considerable amount of sodium chloride salt, which we can get it at the grocery store nearby. I will add a significant amount of heated water, making sure it matches the salt in the cup, and then I will give it a good stir. Finally, I will stir it until all salt gone for good. I will separate them into another container with larger area compared to the previous cup. So here is my sodium chloride crystal that is formed after a week. As we can observe here, they typically look like tiny square shaped blocks with straight edges and flat surfaces. These blocks are formed because the particles in salt arrange themselves in a repeating pattern, making these cube-like shapes. Before we describe the structure of sodium chloride, it is important to know what is crystallitis, a structural representation of the atoms of a molecule in the form of crystal. The structure is formed by the repetition of a small structure called a unit of crystal. Sodium chloride crystals form the face-centered crystal with a cubic unit cell. Each sodium atom is surrounded by 6 atoms of chloride, and vice versa. The coordination number is 6 due to one sodium ion can bond with 6 chloride ion and vice versa. The total number of sodium and chloride ion present are 4, which can be determined by counting the atoms in each sites like shown here. Salt dissolves in water due to the polarity of both substances. Water molecules are polar with a positive and a negative end, while sodium chloride salt consists of ions, sodium and chloride, held together by ionic bonds. When salt is added to water, the polar water molecules surround the individual sodium and chloride ions from the salt crystal. The positively charged hydrogen atoms of water are attracted to the negatively charged chloride ion, and vice versa. This attraction disrupts the ionic bonds between the sodium and chloride ion in the salt crystal, causing the ions to separate and become surrounded by water molecules. Concerning the formation of crystals from dissolved salt water, when water evaporates, the dissolved ions in the water become increasingly concentrated. As more water evaporates, the concentration of ions reaches a point where they begin to come closer together. Eventually, the ions attract each other and recombine to form solid crystals again, similar to how they were in the original salt crystal. This process is called crystallization. As water continues to evaporate, the ions bond together in a repeated pattern, forming a crystal lattice structure and solidifying into salt crystals once more. I think that's all from me. Thank you.